next talk is from Lefteris Manasakis. Right? I got it right. Who will be presenting Bogons Observatory. Lefteris is a co-founder and chief operating officer of Code BGP and is coming to us today from the island of Crete in Greece. This is Lefteris' second time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome back to NANOG.
Thank you, Chris, for the introduction. I must say that right now in Greece, it's 2 a.m. in the morning. So normally at this hour, I see my seventh dream, something like that. Hopefully I will not sound too sleepy, although Valerie let me have a dry run a bit later, so I managed to get a nap. It's the second time in a row that I present at NANOG. The first time I talked about Bogons, about BGP zombies, sorry. This time about Bogons. I'm always interested in the weird BGP stuff. I cannot hide it anymore, obviously. The first time I came across the term Bogons, I was a kid. I was like 20 years ago almost. And I found them fascinating, why they exist, what is behind them. Even the name Bogons, the way it sounds for a Greek kid who's not a native English speaker, sounded very cool. So I always wanted to study them. A few months ago, I had the idea of studying the Bogon phenomenon using the core BGP platform. And this is how this project came about. Short who am I? I'm a researcher with network engineering background. I'm interested in topics related to network internet measurements and routing security. And a few years ago, together with my research collaborators Fontas and Vasilis, we dropped research. We founded Code BGP. And also we built a Code BGP platform, a BGP monitoring software as a service. This talk is about the Bogons, studying the Bogon phenomenon, as I said. But before we study the Bogons, we must first define what a Bogon is. It's interesting how many different answers you get to the question, what is a Bogon, depending on who you ask. So let's figure that out. Martians are private and reserved addresses defined by RFCs. Traditional Bogons include the Martians, but also include the prefixes that have not been allocated to regional registries, like ARIN, for example, by the Internet Assigned Numbers Authority, by IANA. Whereas full Bogons contain the traditional Bogon prefixes, but also include the IP space allocated to the regional registries, but not yet assigned by them to local registries, like companies and individuals, for both IPv4 and IPv6. This definition is from Tim Camry's website, and it's one we will use throughout this presentation when it comes to the prefixes. These are some IPv4 Martians, so we are all on the same page, and some more. Actually, I have a typo there, I think, anyway. And some IPv6 Martians, and some more. When it comes to bogus autonomous systems, similarly to prefixes, an autonomous system should be termed as Bogon if any of the following conditions is true. It is reserved for special use by an RFC, like private ASNs, for example. It is not part of the block assigned to a regional registry by IANA, or it is not assigned to a local registry by a regional registry. Again, some examples of reserved and unallocated autonomous systems, and some more. The dashes indicate AES ranges, and especially for the 4-byte ASNs, the unallocated ASNs are billions, essentially. Now, why we care about Bogons is a question someone might have. They are usually the result of configuration mistakes. When you see a network linking Bogons to the global routing table, in order to be polite, I would say it's an indication they do not apply proper filtering. However, sometimes they are also found as the source for various types of misconduct. Source addresses of DDoS attacks might be a case, although yesterday I got feedback that this is not very common. However, I would like to study it. BGP security events, such as hijacks and route leaks, and other types of nefarious internet activity. These are some of the well-known Bogon projects that exist for decades. The CIDR report by Geoff Houston, Tim Camry's Bogons project, and Hurricane Electrics. I have links for each project in the presentation. You might wonder, since so many projects already exist, why bother having another, right? The main differences between our project and the previous projects that I mentioned is that our project provides real-time data. By real-time, we mean within seconds, from multiple worldwide distributed locations. By multiple, I mean hundreds, via multiple BGP feeds for all possible Bogons, full-bogon prefixes as I defined them before, and Bogon ASes anywhere in the AS path. So these are the main differences of our project. In order to collect routing data for our project, we use the core BGP monitor, which is the BGP monitoring service we developed. It is based on iBGP and route reflection, so the next hop is not altered. This way, we can identify from which router we received each update. This is important if you want to have granular data in terms of visibility, where you got each update from. We collect the routes in our own route collectors, and we propagate them to the core BGP platform instance without letting the BGP best path selection algorithm kick in, since it would hide the alternative paths and provide only the best paths, obviously. The way we do that is we use the BGP add path capability. In this slide, you can see details regarding the number of peers we have currently, the geographical distribution and number of upstreams. We have some Tier 1 upstreams as well. This map provides the locations for all our monitors, and it's a visual representation of what I described in the previous slide with words. The monitors, which in reality they are virtual machines running BIRD, the BIRD routing software, receive dual-stack full BGP tables from our upstreams, forward them to our route collectors, and from there, the data are filtered and propagated to the core BGP platform. The core BGP platform instance we have set up to study the Bogons receives data from 220 monitors currently. Essentially, there are 110 routers that are dual stack, and this number constantly increases. It is configured to monitor full Bogon prefixes, as I said, and Bogon ASes, which are present anywhere in the AS path. Okay, we have talked about the project's underlying infrastructure, and now we need to explain how we identify Bogons and how we collect Bogon data. RIPE NCC publishes daily a large CSV file which contains the prefixes and autonomous systems that have been assigned to local registries based on data gathered from all five regional registries. I didn't know about this, and my friend Max Tucci from Internet Society told me in a taxi in Copenhagen in particular, right after DKNOG, the Danish network operators group, while I was pitching to him the Bogons idea, so the credit goes to him. The first step of the methodology is that a script checks every hour, basically checks the checksum of the file if it's different, and downloads this file, identifies all the entries that are either available or reserved, and creates two lists, the Bogon prefixes and the Bogon ASNs. These two lists are used to update the BIRD BGP filters of the core BGP monitor route collectors. And the last step is the Bogon ASNs and prefixes are forwarded to the core BGP platform via BGP. This URL is of the actual CSV file and a link with documentation on how this file is created by RIPE NCC, if anyone is interested. The second URL is an interesting case because I was looking for it, I couldn't find it, and my friend Emil Laben from RIPE NCC gave it to me a few days ago. And this is how the CSV file looks like. In the beginning, it contains all the AESs, and you can see in this print screen examples of available and reserved autonomous systems. Those are the ones the script picks up, essentially. And later in the file, we have the prefixes. And again, you can see in the print screen available and reserved prefixes, along with their subnet mask. This screenshot contains an example of a BERT filter containing only Martians, which is heavily inspired by the NL-NOG BGP filter guide. You can find the references for this in the previous slides. I just want to say that I include in this script, in this filter, only Martians and unallocated ASNs, because if I did the full Bogons, it would be so huge, nobody would be able to see anything. It is also interesting to notice that BERT supports AS ranges. So you don't have to put all the ASNs one after the other. It will be a disaster in the configuration file. You can do it using ranges. And actually, BERT supports this huge filtering without even breaking a sweat. It's an amazing piece of software, I should say. This table provides a data comparison snapshot for April 18 between the Bogon projects. Our own project reports at least 6 times more active Bogon routes, and we are talking only about best routes, not taking into consideration the add path. And probably this is the side effect of the fact that we have hundreds of routers that we get data from, and not just one router. This table provides a data comparison snapshot again for April 18 between our project and Team Camrys in terms of number of prefixes that should be part of full Bogon prefix filters. It's a different thing here. We're not talking about active routes. We're talking about the actual prefixes that you should use if you want to do full Bogon prefix filtering. Our own project reports 8 times more IPv4 prefixes and twice more IPv6. What we observe is that our results are a superset of Team Camrys. All their prefixes are included in our dataset, but probably they have a methodology which excludes certain prefixes. And I must say, I would love to know what that methodology is. This table provides the RPKI valid and invalid routes for April 18 again. You might be wondering how it's possible an RPKI valid route to be a Bogon, which is a valid question. The answer is due to the presence of Bogon Autonomous Systems in the AS path. So you might have a valid route, but there is a Bogon AS in the path, which essentially makes the route a Bogon route. We provide an open source repo, and I must say that I should thank my friend and shepherd for this presentation, Fergus Mackay, for this. He pushed me to do this. It was not in the plan. So we provide an open source repo which contains a shell script implementing the methodology I just described. The shell script is written by my good friend and co-worker in CodeBGP, Yannis Paterakis, which implements the methodology. A BERT template configuration, like the one that I showed you before. A Python script for MRT dumps, which is developed by Max Tucci and Aftab Siddiqui of Internet Society, and somebody can use that in order to download MRT dumps from RouteViews and RIPE RIS and do historical analysis for the Bogon phenomenon, even if you don't have a router, and a README for detailed steps, with detailed steps. Another option to study the Bogon phenomenon is to use our platform. There are some steps you can follow in order to sign up for free. And this is how the sign-up process looks like. It's quite easy. By using the Bogon instance, we can make sure we don't announce or propagate Bogon prefixes. make sure we don't use or propagate Bogon ASes, and figure out who does it, and let them know so they fix their announcements and filters. This is the overview page of the platform, which I must say it only contains Bogon routes and the prefixes related to those routes. No more features. It's not a full-blown core BGP platform instance with oral features. It contains only routes and prefixes. This is how the routes table looks like, and I chose this example to show you a typical case of misconfiguration which results in a bogus route. AS 134105 is announcing their prefix, and this route happens to be RPKA valid. This is one of the cases I described before. Note that the number 2 in brackets indicates the AES is prepended 2 times in this specific route. However, along the path, AES 133385 decides to prepend themselves 4 times. But in one of the prepends, they accidentally add 1 digit in the middle, the number 3, as you can see. This prepend implies that maybe, I'm assuming, a MikroTik router is used in order to achieve such a prepend. If you click on the route, you can also see the core BGP monitor router, which shows this update, where it's geographically located, and our peer IP and our upstream. This, of course, is true for all the routers, for all routes, and for all prefixes. At the bottom, you will notice in the red circle, on June 1st, when I took this screenshot, there were more than 140,000 Bogon routes in the platform. In general, the number fluctuates between 100,000 and 150,000. Because we're talking about active routes only. Whenever a withdrawal takes place, the route is removed from the database of the platform. This number sounds huge, obviously. Before we talked about 6,000 routes, not 140,000. So I need to explain why this is true. The reason we have so many Bogon routes is because each one of our monitors can potentially provide a different route for the same AES prefix combination, based on the fact that the AES path changes for each monitor. And we leverage the add path capability as well. Therefore, we see all the paths, not only the best ones, as I said. We also provide an on-mouse over functionality for the prefixes and ASNs. You can use this functionality to be redirected to RIPE, for example, or Cloudflare's Radar, IRR Explorer, and PeeringDB. And for this case, if you click on RIPE, you will find out why this weird AES is bogus. In this case, it's unallocated by ANA, basically. Well, with the AES path filter, you can search for specific autonomous systems that are present in bogus routes. So, for example, you can check your own AES or use regex and check for specific AES path patterns. In general, you can use all the available search fields to find what you're looking for. The same applies for the prefixes table. Under each prefix, we have a subtable which provides information about the routers that are seeing this prefix and where they are located. As you can see, the prefixes table has more than 10,000 entries on June 1st, when I took the screenshot. This does not mean that there are 10,000 active Bogon prefixes out there, right? What it means is that there are 10,000 prefixes present in Bogon routes, which again, in a lot of cases are labeled as bogus due to the presence of Bogon ASNs in the AES path. Same as with the routes, you can search for specific prefixes and also use regex for more fine-grained prefix filtering. Now, in terms of next steps, during my previous presentation on Nanog, right after actually, I met John Christoph, and we decided we'll collaborate on this project. So, and also other people have joined us, Max Tucci, my co-founder and CTO and friend Vasilios Kotronis and other people have joined this project. We will conduct a measurement study for the Bogon phenomenon that could result in a publication. We will try to correlate, that's one of the ideas we have. There are many ways you can see this. Try to correlate Bogon data with DDoS attacks, BGP hijacks, and other security-related events. Try to see if there is any correlation there. Another goal I have is to seek funding to develop a methodology, an automation. Basically, the methodology is already developed, but mostly the automation that will periodically inform people about their misconfigured BGP filters. But what needs to be added in the methodology, and that's the idea, that's actually an idea by Max Tucci, which I really like, is to provide the people that leak Bogons ready-made filters in various vendors so that they can use them as is in order to stop leaking Bogons. The goal obviously is an internet with less Bogons. I want to thank a lot of people for this presentation that have helped. My entire team at CodeBGP, almost 10 people, especially Yannis Paterakis and Corina Kalergi, Max Tucci, Fiegas Bakay that I mentioned, John Christoph, of course. And also I want to thank you all for your attention, and I would love to hear your questions.
Hi, David Swafford here. I'm curious about the last slide where you're talking about potentially providing a feed or a list of the Bogons.
Let's see if I can take it back. This one?
I believe so. I was curious, have you given much thought on how to keep the list of Bogons updated? For example, are you thinking about automation where providers would somehow subscribe to a list of Bogons, or is it more of a static?
So the idea is, and I would love feedback from people about this, the idea is that there will be an automation that will collect all the Bogon data, the way we do it, identify from who is data, probably, and message the Bogon, the people who leak Bogons, and inform them that this is happening, but not only inform them that this is happening, provide also a filter, like a configuration in different formats that they can use in order to stop doing this, basically. That is the original idea. Not sure if it will work and how it will work exactly, but yeah, this is what we've thought, and I would love to hear feedback about this.
Yeah, I think that would be great, because I just think back to when I used to maintain my own access lists that would define like RFC 1918 space and stuff like that. And coming up with a way to make it more automatable and automatic would be very, very helpful. So thank you.
Thank you.
Hi, Rich Compton from Charter. I'm curious if you did any research looking at the squat space and how that's being advertised or leaked from internal networks to the internet.
About squatting, we have done research, but this is not part of this project. But yeah, there is research on IP squatting, actually extensive research. This is something that is happening a lot, and especially as far as I remember, it includes the Department of Defense IP space.
Yeah, I was specifically referring to that Department of Defense space.
I know that, I cannot say, unfortunately, because I have signed an NDA about this, that some people are measuring this, but yeah.
Okay, thanks.
Hi, Tony Taubert, Comcast. I'm not sure if you touched on it or not, but this is, something that people should be aware of. The cycle, the sort of business cycle, I guess, at the RIRs can be such that if there's something that's registered, then there's a billing dispute or what have you, some administrative reason that things become unregistered, and the exact timing and methodology varies across the different RRs. So there can be.
Yeah, you're right, Tony. So depending on the regional registry, this process varies. So in some cases, they hold the prefix, when somebody returns the prefix or the autonomous system, they hold it in reserved mode for 3 months, for example. In other cases, for more or less time, and then they make it available. That's one notable difference. Another thing that I have gotten as feedback having these discussions is that in some cases, there are lost contacts. For example, there is one person who's working for a company, he leaves or he retires, Erin, for example, and that's a feedback I got a few minutes ago by Stephen Wallace from Internet 2. This person retires, Erin keeps emailing this person, obviously they don't get a reply, and they put it in the full-bogon's list, this ASN, for example, and nobody knows this. So I hope that this presentation raises our awareness around this phenomenon so that we collectively make something better about it and fix it eventually, hopefully.
Absolutely.
Let's hope.
Thanks very much.
Thank you. Thank you very much.